as far as we can tell. The laws of beta decay that we talked about at a previous time, are these also time reversible? The difficulty of the experiments a few months ago, which indicate that there is something the matter, some unknown about the laws, and I think on this he's talking about the muon stuff, the meson decay, suggests the possibility that in fact beta decay may not also be time reversible, and we shall have to wait for more experiments to see. But at least the following is true. Beta decay, which may or may not be time reversible, is a very unimportant phenomenon for most ordinary circumstances. The possibility of my talking to you does not depend on beta decay, although it does depend on chemical interactions. It depends on electrical forces, not much on nuclear forces at the moment, but it also depends on gravitation. But I am one-sided. I speak and a voice goes out into the air, and it does not come sucking back into my mouth when I open it. And this irreversibility cannot be hung on the phenomenon of beta decay. In other words, we believe that most of the ordinary phenomena in the world, which are produced by atomic motions, are according to laws which can be completely reversed. So we will have to look some more to find the explanation of the irreversibility. If we look at our planets moving around the sun more carefully, we soon find that all is not quite right. For example, the Earth's rotation on its axis is slightly slowing down. This is due to tidal friction. And you can see that friction is something which is obviously irreversible. If I take a heavy weight on the floor and push it, it will slide and stop. If I stand and wait, it does not suddenly start up and speed up and come into my hand. So the frictional effect seems to be irreversible. But a frictional effect, as we discussed at another time, is the result of the enormous complexity of the interactions of the weight of the wood, the jiggling of the atoms inside, and the organized motion of the weight is changed into disorganized, irregular wiggle-waggles of the atoms in the wood. So therefore, we should look at the thing more closely. As a matter of fact, we have here the clue to the apparent irreversibility. I will take a simple example. Suppose we have blue water with ink and white water, that is, without ink, in a tank, with a little separation, and then we pull out the separation very delicately. The water starts separate, blue on one side and white on the other. And then we wait a while, and gradually the blue mixes up with the white, and after a while the water is Luke blue, or sort of 50-50, the color uniformly distributed throughout. Now if we wait and watch this for a long time, it does not by itself separate. You could do something to get the blue separated again. You could evaporate the water and condense it somewhere else and collect the blue dye and dissolve it in half the water and put the thing back. But while you were doing all of that, you would yourself be causing irreversible phenomena somewhere else. By itself, it does not go the other way. So that gives us some clue. We look at the molecules. Suppose that we take a moving picture of the blue and white water mixing. It will look funny if we run it backwards because we shall start with uniform water and gradually the thing will separate and it will obviously be nutty. Now, if we magnify the picture so that every physicist can watch atom by atom to find out what happens irreversibly, where the laws of balance of forward and backward break down. So you start and you look at the picture. You have atoms of two different kinds. It's ridiculous, but let's call them blue and white, and they're jiggling all the time in thermal motion. If we were to start at the beginning, we should have mostly atoms of one kind on one side and atoms of the other kind on the other side. And now these atoms are jiggling around, billions and billions of them, and if we start them with one kind all on one side and the other kind on the other side, we see that in their perpetual irregular motions, they will get mixed up, and that is why the water becomes more or less uniformly blue. So let us watch any one collision selected from that picture, and in the moving picture the atoms come together this way and bounce off that way. And now run that section of the film backwards and you find the pair of molecules moving together the other way and bouncing off this way. And the physicist looks with his keen eye and measures everything and says, that's all right, that's according to the laws of physics. If two molecules came this way, they would bounce off that way. It is reversible. The laws of molecular collision are reversible. So if you watch too carefully, you cannot understand it at all, because every one of the collisions is absolutely reversible, and yet the whole moving picture shows something absurd, which is that in the reversed picture, the molecules start in the mixed condition, blue, white, blue, white, blue, white, and as time goes on through all the collisions, the blue separates from the white. But they cannot do that. It is not natural that the accidents of life should be such that the blues will separate themselves from the whites. And yet if you watch this reversed movie very carefully, every collision is okay. Well, you see that All there is to it is that the irreversibility is caused by the general accidents of life. If you start with a thing that is separated and make irregular changes, it does get more uniform. But if it starts uniform and you make irregular changes, it does not get separated. It could get separated. It is not against the laws of physics that the molecules bounce around so that they separate. It is just unlikely. It would never happen in a million years, and that is the answer. Things are irreversible only in a sense that going one way is likely, but going the other way, although it is possible and is according to the laws of physics, it would not happen in a million years. It is just ridiculous to expect that if you sit there long enough, the jiggling of the atoms will separate a uniform mixture of ink and water into ink on one side and water on the other. So I love that. It's basically just saying it could happen.
Right. The way I look at it is it's like, I think he might say this later, but it's about the number of possibilities, right? Like here's all the possible things that could happen.
Yeah.
And so separating into the uniform, blue on one side and white on the other side is like an extremely limited number of possibilities.
Yeah.
Whereas
it's
any other arrangement is
Yeah.
has like infinite possibilities.
Right.
So that
out of all the possible configurations of the billions and billions and billions of molecules, there's only one very specific one where it's separated.
Right.
Where there are trillions and trillions and trillions of possible configurations where they're not.
Right.
So the likelihood that you'll land on this particular separated one is very low.
Yeah.
But not impossible.
So in the vast expanse of the universe and time, some very unlikely things happen.
Yeah. Yeah. And I bet that, for example, if you ran this experiment and they did configure themselves into blue and white, then the first thing the person would look for is some outside force causing it to take place rather than just probability. Because that's the first thing you think of, like, what made that happen?
Yeah.
Something pulled all the blue ones over to this side somehow.
Yeah.
Okay, so going on with Feynman, he says, now, if I had put a box around my experiment so that there were only 4 or 5 molecules of each kind in the box, as time went on, they would get mixed up. But I think you could believe that if you kept watching in the perpetual irregular collisions of these molecules after some time, not necessarily a million years, maybe only a year, you would see that accidentally they would get back more or less to their original state, at least in the sense that if I put a barrier through the middle, all the whites would be on one side and all the blues on the other. It is not impossible. However, the actual objects with which we work have not only 4 or 5 blues and whites, they have 4 or 5 million, which are all going to get separated like this. And so the apparent irreversibility of nature does not come from the irreversibility of the fundamental physical laws. It comes from the characteristic that if you start with an ordered system and have the irregularities of nature, the balancing of molecules, then the thing goes one way. And that's another way of saying what we were just like. The order is one state. There are millions of disorderly states.
Right.
There's only one, or very few at least, maybe not just one, but there's very few states where it's in order. Or much fewer.
So even though there might be billions of possible collisions that would result in ultimately all of the atoms being separated, there's so many more possibilities of the random distribution.
Yeah.
That that's the point. There's a lot of possible ways that they could collide that would ultimately result in them being separated.
Yeah.
But not nearly as much as
if you got a trillion blue molecules, they could have lots of configurations on one side.
Yeah.
But the number of configurations where they're all mixed up together is just
vastly
so much
greater.
more. Yeah. Yeah, you're right. Okay, so therefore the next question is, how did they get ordered in the first place? That is to say, why is it possible to start with the ordered? The difficulty is that we start with an ordered thing and we do not end up with an ordered thing. One of the rules of the world is that the thing goes from an ordered condition to a disordered. Incidentally, this word order, like the word disorder, is another of these terms of physics which are not exactly the same as in ordinary life. The order need not be interesting to you as human beings. It is just that there is a definite situation, all on one side and all on the other, or they are mixed up, and that is ordered and disordered. The question, then, is how the thing gets ordered in the first place, and why, when we look at any ordinary situation, which is only partly ordered, we can conclude that it probably came from one which was more ordered. If I look at a tank of water in which the water is very dark blue on one side and very clear white on the other, and a sort of bluish color in between, I know that the thing has been left alone for 20 or 30 minutes. And then I will guess that it got this way because the separation was more complete in the past. And if I wait longer, then the blue and white will get more intermixed. And if I know that this thing has been left alone for a sufficiently long time, I can conclude something about the past condition. The fact that it is smooth at the sides can only arise because it was much more satisfactorily separated in the past, because if it were not more satisfactorily separated in the past, in the time since then it would become more mixed up. It is therefore possible to tell from the present something about the past. In fact, physicists do not usually do this much. Physicists like to think that all you have to do is say, these are the conditions, what happens next? But all of our sister sciences have a completely different problem. In fact, all of the other things that are studied, history, geology, astronomical history, have a problem of this other kind. I find that they are able to make predictions of a completely different type from those of a physicist. A physicist will say, in this condition, I'll tell you what will happen next. But a geologist will say something like this: I have dug in the ground and I have found certain kinds of bones. I predict that if you dig in the ground, you will find a similar kind of bone. The historian, although he talks about the past, can do it by talking about the future. When he says that the French Revolution was in 1789, he means that if you look in another book about the French Revolution, you will find the same date. What he does is to make a kind of prediction about something that he has never looked at before, documents that have still to be found, and he predicts that the documents in which there is something written about Napoleon will coincide with what is written in other documents. The question is how that is possible, and the only way that that is possible is to suggest that the past of the world was more organized in this sense than the present. Some people have proposed that the way the world became ordered is this. In the beginning, the whole universe was just irregular motions, like the mixed water. We saw that if you waited long enough with very few atoms, the water could have gotten separated accidentally. So some physicists about a century ago suggested that all that has happened is that the world, this system that has been going on, fluctuated. That is the term used when it gets a little out of ordinary uniform condition. So it fluctuated, and now we are watching the fluctuation undo itself. So you may say, but look how long you would have to wait for such a fluctuation. I know, but if it did not fluctuate far enough to be able to produce evolution, to be able to produce an intelligent person, we would not have noticed it. So this is like the anthropic principle, basically, he's putting in there, right? Like, well, yes, it had to be. Yes, you can point out like how big this fluctuation was, but what he's saying is it had to be that big for you to be here to point it out. So it isn't actually that surprising that it's a big fluctuation.
Yeah.
So we had to keep on waiting until we were alive to notice it. We had to have at least that big a fluctuation. But I believe this theory to be incorrect. I think it is a ridiculous theory for the following reason. If the world were much bigger and the atoms were all over the place starting from a completely mixed up condition, then if I happened to look only at the atoms in one place and I found the atoms there separated, I would have no way to conclude that the atoms anywhere else would be separated. In fact, if the thing were a fluctuation and I noticed something odd, the most likely way it got there would be that there was nothing odd anywhere else. That is, I would have to borrow odds, so to speak, to get the thing lopsided, and there is no use borrowing too much. In the experiment with the blue and white water, when eventually the few molecules in the box became separated, the most likely condition of the rest of the water would still be mixed up. And therefore, although when we look at the stars and we look at the world and we see everything is ordered, if there were a fluctuation, the prediction would be that if we looked at a place where we have not looked before, it would be disordered and a mess. Although the separation of the matter into stars which are hot and space which is cold, which we have seen, could be a fluctuation, then in places where we have not looked, we would expect to find that the stars are not separated from space. And since we always make the prediction that in a place where we have not looked, we shall see stars in a similar condition, or find the same statement about Napoleon, or that we shall see bones like the bones we have seen before, the success of all those sciences indicates that the world did not come from a fluctuation,